Alright, so for Alright, so for titration, as we said before, the basic principle is that we want to find out the concentration of a solution whose concentration is unknown. So for example, if you have some hydrochloric acid, right, and we don't know the concentration of it, we can do a titration. Now, we would react the hydrochloric acid with a base. For example, sodium hydroxide. But before we do it, we would have to know the concentration of the sodium hydroxide solution that we are using. And the reason for that is we know that when sodium hydroxide and hydrochloric acid reacts, they react in a particular ratio. And we can use that ratio to figure out how many moles of hydrochloric acid react. So for titration, we have a solution whose concentration is unknown. And we react it with another solution whose concentration is known. And just based on that simple principle, we can figure out the concentration of the unknown solution. Now we have different types of titration. We have acid-base, redox, thermometric, right? We also have potentiometric. But for the calculations, we're going to focus on acid-base calculation, redox, and back titration. Now, redox titration and acid-base, they are practically the same. The main difference is how we arrive at the equivalence point. Now, all of us are familiar with acid-base titration and what happens. We know that acids are colorless. We know that bases are colorless as well. And when we react the two of them, they will neutralize each other. But even at the point of neutralization, we will not be able to see it because both solutions are colorless. And so that is why for acid-based titrations, we have to use an indicator. The indicator is the substance that tells us that the acid and the base have neutralized each other. So if you are doing an acid-based titration and you forget to add the indicator, you will not get a color change. Because even when neutralization occurs, both will remain colorless. So the indicator is very important, right? That gives you the endpoint of the titration. So whenever the indicator changes color, we refer to that as the endpoint. The equivalence point is a little different from the endpoint. The equivalence point is when the acid and the base, right? So let me just do an equation and explain it. So when sodium hydroxide reacts with hydrochloric acid, we know we will get sodium chloride and water. When you balance it, it's already balanced, right? So it's a 1-to-1 mole ratio. So based on this equation, right, sodium hydroxide and hydrochloric acid react in a 1-to-1 mole ratio. The equivalence point is when the number of moles of these two substances are equal to each other. That is when we say the sodium hydroxide and the hydrochloric acid have neutralized each other. Now the endpoint is when the indicator changes color. It doesn't have to change color immediately as the sodium hydroxide and the hydrochloric acid neutralize each other. However, it must happen very close to the equivalence point, right? So just to make that clear, the endpoint is when the indicator changes color. But the equivalence point is when these two react equally. If it was a case where it's a 2-to-1, if it was a case where it was a 2-to-1 mole ratio, the equivalence point would be when we have accomplished this ratio. So the equivalence point is based on the mole ratio from the balance equation. So when 2 moles of sodium hydroxide would have reacted with 1 mole of HCl, they would have neutralized each other. The endpoint is where the indicator changes color, right? But next week's class, we will look more at indicator and how to select the different types of indicator. For this class, I just want to focus on the calculations. So the main thing that we're figuring out here is to calculate concentration. Now, when we make a solution, we know that we are dissolving a solute, a particular amount of solute in a solvent, right? That's it. You want a solution, you dissolve solute in solvent. For example, sodium chloride in water. Now, for you to know the concentration, you have to know both of these. You cannot know the amount of solute, but not the solvent. Because as you can see, you're dividing the solvent by the solute by the solvent, right? So for concentration, you have to know these two. If you don't know these two, all you have is a solution. But when you know the solute, the amount of solute, typically it is in grams because you're going to weigh it. And the solvent is going to be in dm cube, right? The volume. So if you just get a container, right, and you just pour some water inside of it and add some chemical, whether sodium hydroxide, any chemical, you cannot calculate the concentration because you did not measure any of these. Now, if you measure the amount of solute as well as the volume, then that solution is what we call a standard solution. So if you had recorded the mass of the solute and the volume of the solvent, then you would, sir, I'm not seeing the board. Exit and come back, Dominique, and let me know. Right, so once you know the mass of the solute and the volume, then you can calculate the concentration. So that solution is a standard solution. It is one in which the concentration is known. Right? Now, in terms of this solute, when we're doing calculations, it can be in terms of moles or it can be in terms of mass. Now, if it is in terms of the solute is in terms of moles, so it will be mole over volume. If it is in terms of mass, it will be mass divided by volume. So we have two types of concentration. We have molar concentration and we have mass concentration. Right? So these are the two types of concentration that you may have to calculate. Molar concentration is mole over volume, mass concentration is mass over volume. And so these two calculations we are going to focus on, right? And we know that in titration, you can be asked to calculate both the molar concentration and the mass concentration. If at any point you have any question, you can ask. All right? So I'm going to erase this and put a titration scenario on the board, and we calculate it. Right, so let us say we do a titration, right? With hydrochloric acid, right? And the objective of this one is to determine the concentration of the hydrochloric acid. So let us say we pipette let us say we pipette 25 cm cube of the hydrochloric acid in our conical flask. And remember, our objective is to determine the concentration. Let's say we are titrating it against sodium hydroxide. For the sodium hydroxide, we would have to know the concentration. Let us say the concentration is 0.5 moles per dm cube. And let's say after the titration, we realized that it took 22.5 cm cube of the sodium hydroxide solution to neutralize it. Right, so this would be our data. We're trying to find the volume of, the concentration of hydrochloric acid, and we have the information for sodium hydroxide. Now, by following a few simple steps, we can figure out the concentration of the hydrochloric acid. Now, in any titration question, you must get the concentration and the volume for one of these substances. Any titration question, you have to get both concentration and volume for one of these substances. And for the next one, you will only get the volume and be asked to calculate the concentration. Whichever substance you get the concentration and the volume, you will calculate the number of moles. So whichever substance you have concentration and volume, you will calculate the number of moles. In this case, it's sodium hydroxide. So the first step in our calculation, we're going to calculate the number of moles of sodium hydroxide. So remember, concentration is mole over volume, therefore mole is concentration times volume. The concentration is 0.50 moles per dm cube. The unit for concentration, as you can see, is moles per dm cube. So we are going to convert the cm cube to dm cube. And we know that 1 dm cube is 1000 cm cube. So to convert from cm cube to dm cube, you would divide by 1000. And so you would end up with 0.0225 dm cube. Let me work on this. Right, so the first step in our calculation is to find the number of moles for this substance you're given, both the concentration and the volume. After you have calculated the moles, you're going to write a balanced equation. Always include state symbols, as you will lose marks. Now, the reason for the balanced equation is so that we can get the mole of HCl. So remember, we're trying to find the concentration of HCl. In order to do that, we need the number of moles of HCl because we already have the volume of HCl. So when we calculate the moles of sodium hydroxide, we can use the mole ratio between sodium hydroxide and HCl to get the mole of HCl. So we know that based on this equation, 1 mole of sodium hydroxide reacts with 1 mole of HCl. So therefore, the mole of HCl is equal to 0.01125 moles. You can take off this and then we will finish off the calculations. And again, if you have any question, you can ask. Is anybody writing at this point? Can I erase the board?
Not yet, sir.
You can let me know when you're finished.
Can go, sir.
Okay. Right, so once we have the moles of HCl, then it's straightforward. We can go ahead and calculate the molar concentration. remember the volume must be in dm cube. Now, you can also be asked to calculate the mass concentration. Now, we know that mass concentration is mass divided by volume. But if the question asks you to find the molar concentration and then the mass concentration, you can just go ahead and multiply the molar concentration by the molar mass of the substance. So if you were to find the mass concentration, you can just go ahead and multiply the molar concentration by the molar mass of this substance. So 0.402 moles per dm cube. And the molar mass for hydrochloric acid is 36.5 gram per mole. So remember, chlorine is 35.5 and hydrogen is 1, so that's 36.5. If you want to know, if you want to check to see if your calculation is actually correct, you can work out the units. If the units does not match up, then the calculation is incorrect. So for this, right, the moles will cancel mole. And so what you're left with is gram per dm cube. And the unit for mass concentration is gram per dm cube. So the unit, you can use it to give you an indication if what you have done is correct. Because if you had divided the molar concentration by the molar mass, then the unit would not match up. So let me just work out that. So it's 14.673 grams per dm cube. Now I'm going to put a question on the board and you are going to work it. But just remember, any titration question, just remember any titration question that you are given, you will get the concentration and the volume for one of the substances. Once you get the concentration and the volume, you are going to calculate the mole. Then you write your balance equation and use mole ratio to find the moles of the substance in which you are trying to find its concentration. Once you get the mole, you divide it by the volume and you have the molar concentration. If they go further and ask you to calculate the mass concentration, you can simply multiply the molar concentration by the molar mass. All right, and that will be it. So again, you can finish writing and let me know when you're finished. I'm going to erase it or still writing. You can stop me. All right, so I'm going to give you about 5 minutes and you attend this. After this question, I'm going to show you how to do back titration and then work some past papers. So at 4:40, I'm going to check and you can tell me your answers. All right, ready? Any answers before we work it? Any answers? Okay.
Yes, sir. Sir.
Yeah, how much you got?
Sir, here?
Yeah, man, I'm here.
Sir, for the molecular concentration, I got 0.3375 mole per DMQ, and for the mass concentration, I got 13.5.
All right, so in this question, it says in the titration, we use 20 cm³ of sodium hydroxide, and it was neutralized by 22.5 cm³ of a 0.15 moles per dm³ sulfuric acid solution. So we got the concentration and the volume for the sulfuric acid solution. And we only got the volume of this sodium hydroxide solution, and we're asked to find the molar and the mass concentration of the sodium hydroxide solution. So remember what I said earlier, every titration question, you will get the concentration and the volume for one of these substances. All right, so first step, whichever substance you get both concentration and volume for, we're going to find the mole, and that is sulfuric acid. So that would be 0.15 moles per dm cube times 0.0225 dm cube. We get 0.00338 moles. You can put this in standard form if you want to.
Yes, sir. I have mine in standard form, Mr. Ian.
All right, so remember, once we find the number of moles, we are going to write a balanced chemical equation. With state symbols.
Sir, so 2 in front of the water and 2 in front of the sodium.
Right. Correct. And as usual, aqueous and liquid. So we know the mole of sulfuric acid, and we want to find the mole of, just a second. Right, we want to find the mole of sodium hydroxide. So based on the balance equation, 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. So it's a 2-to-1 mole ratio. However, we know the mole of sulfuric acid, so we are looking at it from a perspective of 1 to 2. So if we have the mole of sulfuric acid and we are trying to find the mole of sodium hydroxide, what should we do? Multiply by 2 or divide?
Multiply by 2, sir.
Multiply.
That is correct. So the mole of mole of NaOH is equal to 0.0038 times 2. 38 and 38, that's how much? 76.
Sir, I get 6.75 times 10 to the negative 3.
It will be 0.0076. All right. So once we have the mole of the sodium hydroxide, we can go ahead and calculate the molar concentration. What was the volume of sodium hydroxide again?
20.
All right. So that's 0.02 dm cube.
But Mr. Here,
Yeah,
sir, I'm
yeah.
not understanding because I kept mining decimal
Wait,
with
hold
the
on.
standard
Sorry.
form and I got
Wait,
something different.
hold on. A
Yes,
three
sir,
three
this one I
eight.
see.
A 338 and not 38.
Oh.
338 and not 38. Right, so 0.00338 times 2, right? So it's 676, right? Yes. And get 0.338 or something close, Sabrina?
Yes, sir. Yes, sir. I got 0.3375 because I use the standard form.
All right, no problem. And then the mass concentration would be equal to 0.338 moles per dm cube times the molar mass of sodium hydroxide, which is 40 gram per mole. All right, another 13.52 gram per dm cube. All right, so that would be it. All right, so I'll give you a minute to take this off, and then we look at bulk titration. I'm going to plug in my laptop, so the screen probably go for a second. All right, that's good. All right, so we're going to look at bulk titration. All right, so before I forget, this is being recorded. I'm going to post it to my channel, so if you want to view it afterwards, you can check. Let me just do this quickly. So if you want to watch it afterwards, it's Mr. Here's Chemistry Lecture Series. All the recordings are posted here on YouTube. All right, so Mr. Here's Chemistry Lecture Series. Now for bulk titration, it's a little different from the acid-base and redox titration. Those are referred to as direct titration. Bulk titration is called indirect titration. And this is called indirect titration because you don't just go ahead and titrate the two solutions. So like you would just add sodium hydroxide to hydrochloric acid, that does not happen, right? For bulk titration, what happens? So for example, you have, in most cases, our facade, normally it's like something to do with calcium carbonate or impure ammonium hydroxide solutions. So let's say you have a sample containing calcium carbonate. For example, chalk, limestone, eggshell, right? And you want to find out the percentage of calcium carbonate in it, you would do a bulk titration. Now, in a bulk titration, it consists of two main parts. So the first part of your bulk titration, it involves a reaction and then a titration. Right? So your bulk titration, it involves two components, a reaction followed by a titration. Now for this example or this scenario, let us say we're trying to find out the percentage of calcium carbonate in a sample of limestone. All right, so we have our sample, right, with the calcium carbonate. And let us say we are using 3 grams of the sample. Now we are going to react the calcium carbonate with an acid, right? Now we have to react it with excess acid for the reason being we need to ensure that all of the calcium carbonate reacts with our acid. Remember, we are calculating the amount of calcium carbonate present in the sample. If all of the calcium carbonate does not react, when we do our calculations, it will not be accurate because all of the calcium carbonate would not have reacted. So that is why when you look at bulk titration questions, you are always reacting your substance of interest, the analyte, with an excess of a next reagent. And the purpose of that is to ensure that all of what you're interested in is reacted. So in this case, we're going to react calcium carbonate with excess hydrochloric acid. And so for the excess, let us say we are using 100 milliliters of hydrochloric acid with and a concentration of 0.5 moles per dm cube, right? So this would be, so we would have our container, right, with the 100 mils of hydrochloric acid, and we add the 3 grams of calcium carbonate inside of it. Now remember, we have excess hydrochloric acid. So when the reaction has completed, the calcium carbonate would have reacted completely. However, not all of the HCl would have reacted. Now, what we're doing here, so we need to find out the amount of calcium carbonate present. So the first thing we need to do is find the mass of calcium carbonate present. In order to find the mass of calcium carbonate present, we need to find the moles of calcium carbonate. All right? So in trying to find the percentage of calcium carbonate, we need to find the mass of calcium carbonate. In order to obtain the mass of calcium carbonate, we need to find the moles of calcium carbonate. This 3 grams here, this is the mass of this sample. So not all of the 3 grams of the calcium carbonate sample is actually just calcium carbonate. All right. So that is where we have to find out first. Of the 3 grams, what mass of it is just calcium carbonate. And to do that, we need to know the moles of calcium carbonate present. So when we react it with the hydrochloric acid, we are going to use the mole ratio between calcium carbonate and hydrochloric acid to get the moles of the calcium carbonate. However, the issue is we used an excess of hydrochloric acid. So the amount of hydrochloric acid that was used in the reaction, we have no idea how much was used. And that is where the titration part of it comes in. So we carry out the reaction. Not all of the hydrochloric acid has reacted. To find out how much actually reacted, we are going to do a titration. So any unreacted HCl will be used in our titration. So the titration is for the unreacted HCl. So it's HCl, so we're going to do an acid-base titration. So we can use sodium hydroxide. And let us say in this titration, we use 0.1 moles per dm cube sodium hydroxide and 18 cm cube. All right. So remember, we carry out a reaction with 3 grams of the calcium carbonate sample and 100 mils of 0.5 moles per dm cube hydrochloric acid. When the reaction is completed, some amount of the HCl was unreacted. We don't know how much, so we do a titration to figure out the number of moles of HCl that was unreacted. So in the titration, it's an acid-base titration. Let us say we use sodium hydroxide. This is the concentration and this is the volume. That's the end of the procedure. Because remember, in a titration, all we need to find out is the volume of the sodium hydroxide that neutralized the hydrochloric acid. So if it was an experiment, this is what would have occurred. Do a reaction, and reacted HCl, you perform a titration. For the calculations now, all right, can I just take off this scenario so we can go through the calculations? All right, so I have been. So you will have to read the question and break it into two parts. The first part of the question, it will introduce you to the reaction, just like I did, and then it will mention the titration portion in the end. So let us look at the reaction portion again. And remember, I said for titrations or any reaction, if you get the concentration and the volume, work out the number of moles. In the reaction, you would have had the total moles of HCl. All right. So the total moles of HCl. And remember, we used 100 cm3, so that would have been, all right, so let's put the concentration first, which was 0.5 moles per dm cube times the volume, which is 0.1 dm cube. So whatever is used in the reaction, that is the total amount. So 0.5 times 0.1, that would be 0.05. All right. So we work out the total moles of HCl. Then we are going to write a balanced equation. So the calcium carbonate reacted with hydrochloric acid. And we know that when carbonates react with acid, we will get salt, carbon dioxide, and water. To balance it, we would need a 2 in front of the HCl. Now, this is as far as you will go with the reaction. So the first thing we did, we calculated the total moles of the HCl, and then we wrote a balanced chemical equation representing the reaction. All right. So you perform these two steps. Then we're going to pause here and move on to the titration. Again, we have the concentration and the volume for the sodium hydroxide. So we are going to find the mole of the sodium hydroxide solution. And the concentration was 0.1. All right, and so this is the number of moles of sodium hydroxide used in the titration. Now, if this is the amount of moles of sodium hydroxide using the titration. Can anybody tell me the number of moles of HCl that is used in the titration? Does anybody know?
Sir, can you repeat the question, please?
Sir,
So this is the number of moles of sodium hydroxide that is used in the titration. And remember, the unreacted HCl was also used in the titration. So if we use this number of moles of sodium hydroxide, how many moles of unreacted HCl was present? How would
so
we
you no
do?
need to write the equation.
Right? And then use the equation to do what?
Mole ratio.
All right. So remember, in the titration, we are reacting the unreacted HCl with the sodium hydroxide. So it's a 1-to-1 mole ratio between sodium hydroxide and HCl. That means the unreacted HCl is equal to how much?
So that is 0.018 moles.
That is correct. 0.0018. Now, remember in the reaction, we have the total amount of moles of HCl, which is 0.05. And in the titration, we have the unreacted amount, which is 0.0018. So if we know the total amount of HCl and we know the unreacted amount of HCl, how can we find out the amount that actually reacted?
Total minus the unreacted.
Right. So we know the total amount and we know how much did not react. So we just subtract this from the total and we know how many moles of HCl actually reacted. So the unreacted is that. So the amount that reacted is equal to the total minus the unreacted. Right? And that will be equal to 0.05 minus 0.0018.
Sorry, 0.032.
All right, so 0.048 moles. All right, so that's the amount of HCl that actually reacted with the calcium carbonate. 0.048. All right. So remember now that we know,
Sir,
yes,
it's 0.032.
that you get?
Yes, sir.
All right, so 0.05 take away 0.0018. 0.001 is 0.0018.
Oh, sorry, sir. My bad.
Yeah. All right. So once we know the amount of moles of HCl that actually reacted with the calcium carbonate, Sabrina, your mic. Sabrina,
Oh,
Sabrina,
sorry.
your mic. Yeah, thanks. Right. So we know the amount of moles of HCl that reacted with the calcium carbonate. So at this point, we are going to return to the reaction. So the mole ratio between calcium carbonate and HCl is 1 to 2. All right? We know the mole of HCl, and we're trying to find calcium carbonate. So it's going from 2 to 1. We're going to divide by 2. So the mole of calcium carbonate is equal to 0.048 divided by 2, right? And that will give us 0.024 moles. All right? So once we get the number of moles that reacted, you just come back to the reaction, use the mole ratio, and get the mole of calcium carbonate. Now, once we have the mole of calcium carbonate, we can go ahead and calculate the mass. What is the formula for finding mass? Mass is equal to?
Molar concentration times
No, not that
molar
one.
mass.
It would be mole, for this one, it would be mole times molar mass. All right, because we have the mole right here. So we just times it by the molar mass. So it would be 0.024, and the mass for calcium carbonate is 100. So 0.024 times 100, and that will give you 2.4 grams. All right. So in the 3-gram sample, 2.4 grams of it is actually calcium carbonate. So if you want the percentage, is the mass of the compound, in this case calcium carbonate, 2.4 grams. It's the mass of the compound divided by the mass of this sample, which is 3 grams, right? Times 100. Can somebody just work out this? Can somebody?
80%.
How much? 80?
80. Yes, sir.
All right. So it's 80%. All right, let me just go through the process again, and then I'm going to put one on the board. In the question, right? So remember, a reaction occurred between a sample of calcium carbonate and hydrochloric acid. I gave you the mass of this sample, which was 3 grams, and I gave you the volume of the HCl and its concentration, right? Now, I told you that the unreacted HCl was used in a titration, right? And in that titration, it was used with sodium hydroxide. I gave you the volume of sodium hydroxide and the concentration. And I told you to calculate the percentage of calcium carbonate present. So at the first part of the question, you are going to get the reaction. You will get concentration and the volume, right? That's the, and I'm going to calculate the moles. That's the total amount of moles, all right? You also write the balance equation for the reaction. Then I'm going to pause at that point and move over to the titration. In the titration, whichever substance you get the concentration and the volume for, we are going to work out the number of moles. So that would be step 3, right? So we calculated the moles of sodium hydroxide. You will have to write a second balance equation. This one is for the titration. And we need it because we are going to use mole ratio to find out the number of moles of unreacted HCl. All right, put it here. All right, above it. The unreacted HCl. Once you get the number of moles of unreacted HCl, you are going to subtract it from the total amount, and that will give us the amount that actually reacted. Once we know how many moles of it that reacted, that is when now at that point we come back to the balance equation. So step 5, after write the balance equation, you work out the moles that is unreacted, and step 6, you get the moles that actually reacted. And then you come back to the balance equation and calculate the moles of the calcium carbonate. That is step 7. Now, in the question, if you were asked to find molar concentration instead of percentage, if you were asked to find molar concentration for step 8, you would have written molar concentration is equal to mole over volume. And in the question, where you got the 3-gram sample, they would have given you a volume. So let's say 20 cm cube of the sample. All right? Right, but in this case, we're finding the percentage. So you calculate the mass, and then finally now, you put the mass of the compound over the mass of this sample times 100. So break it up into 9 steps. So the first 2 steps is for the reaction, then you move over to the titration. And the whole point of the titration is to find out the number of moles that actually reacted. Find the unreacted first, then the reacted. Now come to the equation, use a mole ratio, find the moles of calcium carbonate. And then the rest is straightforward. All right. So I'm going to take off this, and then I'm going to put the past paper for bulk titration on the board. All right. So whenever you're finished with this, you can let me know. All right, so that's it, and it's for 8 marks. All right, just to make a note, right here, where they say the excess sodium hydroxide, excess here means unreacted. All right, so the excess sodium hydroxide, it means the unreacted sodium hydroxide. And so I'll give you probably 6 minutes for this one. Has anyone gotten an answer as yet? Any answers as yet? Right, I'm going to give you 2 more minutes and then I work it. All right, anybody finish? I want to share their answer. Do you want me to give you some more time or work it? You want some more time to work it, or should I work it?
Work it.
All right. All right. Someone said they got 80%. All right, Dominic. All right. So before I erase the question, let us just highlight some information. So we have a contaminated sample of ammonium chloride. They gave us the mass of it, which is 5 grams. Next now, we reacted, so when they say a sample of it was warm, that is actually the reaction. So it's between ammonium chloride and sodium hydroxide. And they gave us the volume of sodium hydroxide and the concentration. Now, after the reaction was completed, the unreacted sodium hydroxide, it was neutralized. So when they say required, so this part of it is the titration. All right. So the first part, it was the reaction between the 5 grams of ammonium chloride and the 100 cm³ of sodium hydroxide. So the 100 cm³ was the excess sodium hydroxide, right? Now, after that reaction, whatever was unreacted was used in the titration. And so the unreacted sodium hydroxide, it required 25 cm³ of 0.5 moles per dm³ sulfuric acid. So we have 3 compounds, ammonium chloride and sodium hydroxide. That is for the reaction portion. And then for the titration, it's between sulfuric acid and the unreacted sodium hydroxide. So let's solve it. All right, so step 1, we're going to calculate the total moles of NaOH. All right, so we have the total mole of the sodium hydroxide. So step 2, we are going to write the balanced chemical equation. So we know that when you react an ammonium salt with a base, you will get the salt. So you will get sodium chloride, ammonia gas, and water. So ammonium salts and the base, you will get salt, ammonia gas, and water. The salt is the positive ion of the base and the negative ion of the ammonium salt. That is where we get sodium chloride. All right, so remember, after we do step 1 and step 2, we're going to move now to the titration portion. And in the titration, we used sulfuric acid. Let me just check that to make sure. So once we get the mole of sulfuric acid, again, we need a balanced equation. So sodium hydroxide plus sulfuric acid So based on this, two moles of sodium hydroxide react with 1 mole of sulfuric acid. So the mole ratio is 2 to 1 between sodium hydroxide and sulfuric acid. And remember, this is the unreacted moles of sodium hydroxide we're trying to find. So unreacted NaOH is equal to 0.0125 divided by 2 we get 0.00625 moles. So that's the unreacted moles of NaOH. All right, what should happen after I find the unreacted moles of NaOH?
You can minus it from the
Total.
From the total to find the reacted.
Right. So the reacted NaOH is equal to
0.1.
Alright, 0.1 minus
from the 0.0125.
Alright.
Oh, this
625.
6. Okay.
How much was that? Let me see. 0.1 take away. Alright, 0.094 if I round off. 0.094 moles. Alright, so it's total minus unreacted. Alright, so step 4, step 5, step 6. Alright, so we are once we get the amount of sodium hydroxide that reacted, we have finished the titration portion and we are moving back now to the equation the reaction. So after we get the moles of sodium hydroxide that reacted with the ammonium chloride, what's the next step? What would we do with the moles of sodium hydroxide that react with the ammonium chloride? What should happen?
So you're not gonna find a mole ratio.
Right? So 1 mole of ammonium chloride reacts with 1 mole of sodium hydroxide. So what will I do after that?
So that means that it's gonna be the same as over there. So since it's a 1-to-1, they're gonna be
Right,
0.0.
94. So because the mole ratio is, as Sabrina said, 1 to 1 mole ratio, therefore the same amount of moles of sodium hydroxide that reacted will be the same amount of moles for ammonium chloride. And we know that the moles was 0.094. All right, so mole of
Sir,
NH, yes.
sir, for the unreacted, why you divide the 0.0125 by 2?
All right. So we got the mole of, oh, hold on. At times, we're supposed to times. Sorry, we're supposed to times it by 2. Right, so it would be 0.025. Answer that.
Yes, sir.
It would be 0.025. This would be 75. Alright. Right, so the mole now of NH4Cl would be equal
Sir,
to.
but you ask 0.
Hmm?
So no 0.025.
Yes. Alright, so the mole of ammonium chloride is 0.075 because it's the 1 to 1 mole ratio, and the mole of sodium hydroxide that reacted is 0.075. So once we get the mole of ammonium chloride, what are we going to calculate next?
Isn't it the mass?
Right,
Get the mass.
and mass is equal to mole times molar mass. So it will be 0.075 times ammonium chloride. How much you got that?
53.
53.5.
Yeah, again, 0.5.
Right. And we get 4.0 grams, so 0.01 gram. All right. And so the final step, step 9, the percentage is equal to mass of the compound, which is the 4.0,
Or mass is some.
and the mass is some, which is 5 grams times 100. So 4 over 5. 80% is correct. So Dominic, you were right. It's 80%. Uh, So you can take off that one. And we're going to do our redox one after you finish taking this off. We're going to try our redox titration. Let me know when you're finished. Is anybody still writing? All right, so let me erase.
constantly George.
Let me know when you're finished with this part of the table so I can put the rest of the question. Right, I'm going to erase the table now and put the rest. So as you know, you would have to complete the table, right? So remember, it's initial from the final to give you the volume used. All right, so those are the three questions. Each were, well, this is where 2 marks. All right. All right, so I'm going to give you 4 minutes to try it, then we'll work it and wrap up for today. And so this one is the last one for today. And so I'll give you 4 or so minutes to try it and then work it. The molar mass for iron is 56. So you will need that. All right. Any answers? Right, I'm going to work it now. All right, so this one is a little different in that they did not give us a volume for the Fe2 plus, they gave us a mass. All right, so all we know that we use 0.5 gram I mean 0.15 gram of the iron plate for the titration, right? So when they ask us to calculate the moles of Fe2 plus used in the titration, if we use 0.15 gram, we know that the mole is equal to mass divided by the molar mass. And we use 0.15 gram of it, and the molar mass is 56 gram per mole. Right, so that would be the mole of the iron, mole of Fe2 plus used in the titration. Now, based on this equation, we know that 5 moles of Fe2 plus reacts with 1 mole of MnO4, the potassium permanganate. Because it's a redox reaction, we don't include the potassium in it. Right, so it's Fe2 plus the permanganate ion. Right, so it's a 5:1 mole ratio, and we have the moles of iron, and we want the moles of the permanganate ion, so we would divide it by 5 to get the answer. Oh, by the way, what did you get for the volume of KMnO4? Did you use the 3 values in the table?
No, sir, just 2.
Which 2?
The one closest, I think the 35.5 and the 35.45.
Right. So remember, in titration, normally we don't want the volumes that we use, they should not differ, or the difference between the two of them should not exceed 0.1. So the first one was 26, the second one was 25.55, and 25.45. The 26, the difference between 26 and 25.55, it would have exceeded the 0.1. So we always use the closest numbers for the titration. If the 3 of them were close, we would average the 3 of them. But in this case, we're only using the 25.55 and the 25.45 to calculate the volume of KMnO4. By the way, next week is the same time, and it's the same link that I will be using. So it is same link, same time. And we will continue with titration, but look more at where we use indicators, standard solutions, primary standards, as well as some more calculations. All right, so the volume of KMnO4 that we would use would be 20, what did I say? 25.55 plus 25.45. Find the average of that, and we get, let me see. We get 25.5. So this is the volume of KMnO4 used in the titration. So we have the mole and we have the volume. So we can go ahead and calculate the molar concentration. Remember, the volume must be in DMQ, so it is 0.0255 DMQ. And the answer is 0.021 moles per DMQ. Right? So the only difference with this one is that they would normally give you the volume and concentration for the irons, for the solution of iron, right? But they did not do that. They gave you a mass. So we divide by the molar mass to get the moles. All right. And once we have that, we use, as usual, we use the balance equation to get the mole ratio and therefore the mole of KMnO4. All right. And once we have the moles, we divide it by the volume to get the molar concentration. And again, if you get a table, you use the closest values. If the three of them are really close, you can use the three of them. But if two are very close and the next one is not, you just average the two of them, as was the case here. All right, so I'm going to stop here for today and we'll continue next week. Again, this is recorded and I will post it shortly if you need to re-watch it.